Okay, continuing section 5.5, we are going to be making a linear model for each of the tables that we see in example number 31 here. So in our first example, what we always want to make sure is that we do have a linear model, because remember, things are not always necessarily linear. So we want to make sure that there's a constant rate of change for the y's and a constant rate of change for the x's, which make a constant rate of change. So we go from 20 up by 20 here, up by 20 here, up by 20 here, and each of these go up by 5. So we're good. This is definitely linear. So the first thing we're going to do is we're going to find the slope. Well, we just found the slope, didn't we? We found that each of these go up by 20 for the dependent, right? The dependent change is 20, and it is increasing by 20, and then the independent change is 5. And so we actually found the slope by doing the change in y. You remember this? It's been a while since we saw this. The change in y and the change in x. So the change in x here and the change in y here. And of course these are dependent. Instead of being called y, it's c of q, and instead of being called x, it's q this time. But don't let that worry you. Now, we can't use slope-intercept form right away because we don't have the y-intercept. So what we're going to do is we're going to plug in. So y minus, we can use any of these that we want. So let's go ahead and use the second one right here. So y minus 50/40 is equal to, and our slope is 4, and then times our independent value minus the independent value there, 10. So our independent is q, cq. And so now I'll do distributive properties. So y minus 50/40. And oops. And then we have that equaling, and we're going to distribute the 4. So we have 4q, and then minus 40. And one last step, we're going to add 50/40 to both sides, 5,040 to both sides, and when we add 5,040 to negative 40, we're going to get 5,000. So y is equal to 4q minus plus 5,000. And then we don't want y anymore. We want to do the function notation, so we call this c of q. And there we go, there's our model. All right, let's try the next one. So in part B, again, you want to investigate, right? Goes up by 3, up by 3, up by 3, awesome. Up by 2, yep, so it's definitely going to be linear, and guess what we just did? We found that the change in the y's was going up by 3's, and then the change in the x's was 2's. So we found our slope by doing change in y over change in x. And this time, instead of x's and y's, we have x's and f of x's. So now we're going to use the point slope form, y minus, we pick a point. Let's do the first one this time. So y minus 9 equals 3/2 times x minus the x value, which is 1. And then we use distributive properties. So y minus 9 is equal to 3/2 x minus 3/2. And the only problem this time around is that we do have a fraction. So we're going to add in, and I'm going to make 9 into halves, right? So this is 18/2 here. So I'm adding 18/2 to both sides. So adding 18/2 in over here, and that's going to give me y is equal to 3/2 x minus, or plus 18 minus 3, which is 15/2. And then, of course, remember that you can check that and see if it's the correct one by putting other values in. So I'll change to function notation. F of x is equal to 3/2 x plus 15/2. And we know if it's the right model or not because we can see if the other points satisfy it. So let's try 15 and 5. So if we put in x is equal to 5, that would give us 15/2. And 15/2, let's see, 5, yes, 15/2 plus 15/2 is 30/2, which is 15. Bingo. So it satisfies that point. And we'll just make the assumption that it satisfies all of them. So why don't you do the next one?